Hi guys, so this video is in response to a question, and this question involves something called stoichiometry, so the molar ratios from the balanced equation. And it's quite a tricky question, there's a lot going on in it, and it's something that students quite often struggle with, how to use those ratios. So the question says chlorine gas can be prepared as follows. We've got a balanced equation that's given. Now it says the concentration of brine, so brine is just salt, sodium chloride dissolved in water, so sodium chloride in aqueous solution. So the concentration can be assumed to be 4 moles per decimeter cubed. Calculate the mass of sodium chloride in this volume, 250 centimeters cubed of the brine. And then it's a two-part question. You get 1 mark just for that bit. And then it says, if this volume of chlorine gas is produced from brine each day, calculate the volume of brine needed for this chlorine production. And it tells us that the chlorine gas is at room temperature and pressure, that's RTP. So whenever a gas is at room temperature and pressure, that means we use the equation for molar volume. So 1 mole of a gas occupies 24 decimeters cubed or 24,000 centimeters cubed at room temperature and pressure. If it's not at room temperature and pressure and it's got a specific temperature, then we'd use the ideal gas equation. So the first thing we have to do to address this part of the question, calculate the mass of sodium chloride in this amount of brine, we are given a concentration of the brine, which is sodium chloride in water. So we do concentration times by the volume of brine that it's asking us to calculate the mass of the salt for. So concentration times volume over 1,000. We have to divide, magpies are really noisy today. We have to divide our volume in centimeters cubed by 1,000 to get it into decimeters cubed, because our concentration, the volume part of it, is in decimeters cubed. So we get 1 mole of sodium chloride in that amount of brine at that concentration. Then we can rearrange the equation, the moles equations for solids, to calculate mass. So mass is moles times relative molecular mass. So we use the moles we've just calculated, which is 1, times the relative molecular mass. So you'll need a periodic table. Big number, mass number for sodium is 23. For chlorine it's 35.5. Add them together. So it's just 58.5 grams for that mass of sodium chloride. Now moving on to the next bit of the question. So this bit's a little bit more tricky. So we look at the question, what information do we have? Where can we start with this? So we're given a volume of chlorine. The chlorine's at room temperature and pressure. So we can calculate moles of that chlorine gas by doing volume divided by molar volume, and we get 1.04 times 10 to the 8 moles. Now if we look at the balanced equation, we've got a 2 to 1 ratio of chlorine. So if there's no big number in front of something in an equation, that means you've got 1 molar quantity of it. So these are actual moles, these are just molar ratios. So we've got 2 lots of this to 1 lot of this. So what does that mean? What do we do with it? So we've worked out our moles of chlorine. We want to get moles of brine to work out the volume of brine. Calculate the volume of brine. So what we do is we times these moles of chlorine by 2, because we've got twice as much of this compared to this. So moles of brine is moles of chlorine times 2. So we just times that number by 2 to get moles of brine, which is this. Then we can use the equation moles is concentration times volume, rearrange for volume of the brine, and we do moles that we've just calculated divided by the concentration that we're given in the question of the brine, and our volume comes out as 5.21 times 10 the power 7 decimeters cubed.